Hello, everyone. Welcome back to Advent Code 2025. What is today? The 3rd? It is the 12th. So I guess last night, I forget if the final puzzle was out when I recorded last night's. I think it was. But as you know, if you've watched my whole playlist, I was out of town for the first week, so I'm not in any sort of competitive rush to finish these in time. I'm doing them about one per day, I guess, as it turns out. Anyway, on to day 9. Movie theater. You slide down the fire pole in the center of the playground and land at the North Pole Base movie theater. What was in the playground? It wasn't... Oh, it was the... I did the Union Find thing. Wait, wasn't that just connecting... Am I crazy? Connecting junction boxes? That's part of a playground? What? Playground. It does say playground. Contains a giant... Okay, but... Alright, there was a playground there, but we were focused on the lighting, I guess. Alright. North Pole Base movie theater. The movie theater has a big tile floor with an interesting pattern. Elves here are redecorating the theater by switching out some of the square tiles in the big grid they form. Some of the tiles are red. The elves would like to find the largest rectangle that uses red tiles for 2 of its opposite corners. They even have a list of where the red tiles are located in the grid. Your input. So... Looks like probably here to here is biggest, if I had to guess. Here to here might be bigger. That's a rectangle. Yep, that's a rectangle. Very tiny rectangle. Largest was here to here. Okay. Using 2 red tiles as opposite corners, what is the largest area of any rectangle you can make? Well, this seems very simple. If you just compare, like, any 2 points will form a rectangle, right? Even if they're on the same column or the same row as each other. That's a triangle with width or length 1. So we could just iterate over each pair of points. Compute the area, which is very simple, and choose the largest. Now, I suspect part 2 will be something like, oh, yeah, but it's got to be a rectangle that doesn't include any other red tiles. Something like that. So, like, this rectangle is illegal because this one's in the way, and so is this one. But maybe it's okay if they're in the corners, but it's not okay if they're in the center, or the edges are not okay either. I don't know. Something like that. But I don't think I can reasonably prepare for part 2. Part 1 is so straightforward, let's just do it. And then whatever part 2 is, take it as it is revealed. And I think this is another case where like parsing grids is where I don't really want to use text reg explicative because I mean, like, maybe it's possible, but it doesn't really give you any advantage. And you'd have to work hard at it, probably. Right, I'll just call lines and iterate over the rows and the columns in the same way I've done on some previous days. So let's define some types. I don't have very many. You know what? Before I define types, let's import some things. Do I need a map? I guess I just need a set. Right? Because all I need to know is a set of coordinates for the red tiles. Okay. I don't think I need to know the edges of the arena, right? I can compute that post hoc if I need it for some reason. Well, I guess that's not quite true. There's this kind of border around the edge here. If for some reason I needed to know this tile is different from, like... right now, there's no reason I need to know there's a tile north of this red tile. And the way that I'm imagining parsing it, it will become impossible to know that. But I think that's fine. Okay, so data coord is just a coord of int and int, as I so often do. And it definitely needs eq and org if you want it to be in a set. Ree! And we may as well give it show, so we can print those maps. And I think the input is very simple. It's just an S set of coord. So let's write prepare. Prepare of input is S from list of do, Y row from lines of input, XC from the row. And as usual, because I always do things with monad comprehensions and list comprehensions, I need to import control monad guard, which is sort of built into list comprehensions, but not to monad comprehensions. I want to guard that C is a hash, and then return coord of yx. And I think that's it. So does this compile? Oh, of course. I have to produce the x's and y's myself. Wait. Oh, my puzzle input isn't... I didn't... whoops. I forgot. My puzzle input is actually just... It's not a grid. It's already... Yeah, okay, so... Maybe... I mean, okay. In this case, I suppose... I was imagining I was planning to parse this, but our actual input is this. I mean, text rank explicative is overkill for this, but it's an appropriate tool at least. So I like using it when it's appropriate, even if it is overkill. So give me the match operation. Give me sum. Give me symbols. I think that's it. And give me a way to parse ints, please. Throw all of this away, please. I did on import guard, okay. Oops. I'm gonna have to import that though. Input is some tile. Tile is just, well, I'll put the new lines not in the definition of tile, but in how the input contains them. I think this is just an aesthetic choice that doesn't matter. Tile is a coord of a decimal followed by a comma we ignore, and then another decimal. And give me from maybe. Does this compile? Oh, yes, I do have to turn this into a set. Great. So we parse some tiles, and we from list the resulting list of tiles, and a tile is just a coordinate wrapped around some decimals surrounded by a comma. So let's confirm that we actually can parse the input. And we can, great. So part 1, what are they actually asking me here? The area of the largest? Yeah. So we want to return an int. Tiles? I mean, there's no real reason this should even be a set. I guess it could have been a list, but that doesn't really matter. I think it being a set will probably be important for part 2 somehow, maybe? Yeah, that's probably true. Maybe. Maybe like an int map, because like this construction is not an easy. It doesn't make it easy to look up, you know, are any of these 500 tiles in the set, right? Which I imagine what we're going to have to do next. Whereas... I imagine if I had like a map from row to set of coord, it would actually be a lot nicer, right? Because then I could trim down the map and say, give me the submap containing only rows 5 to 7. And you could, maps can do that reasonably efficiently. And then say for each of those rows, give me the subset containing columns 10 to 20. And then say, all right, is the resulting set empty or not? Basically. I think you'd have to be a little bit more careful because that would include the starting tiles. But I don't know, maybe the way it handles borders. We would want the corner. I don't know how we want to handle the edges anyway. So I think that if my goal were to have a clean part 2, sort of, which in some sense I think best reflects my understanding. Like, I like having a nice simple part 2 because it indicates that my definition for part 1 was a good representation of the problem domain, rather than being laser focused on implementing exactly the one thing they asked for in part 1. Right? Often, especially in the early days of advent of code, you can just like write some function that doesn't really build up any domain objects. You just like fold over the list of characters in the input stream and do something cute, and like you have the answer. And then for part 2, that function doesn't help you at all. And there's nothing wrong with that, especially if your goal is to do things quickly. But since my approach is generally to define a reasonable domain model and then encode the goal of part 1 as like some function over that domain, I interpret it as, you know, hey, you did a good job in part 1 if your part 2 is pretty simple. If your change for part 2 is minimal, it means you have the right tools already in place from part 1. So if I wanted to minimize part 2, I think that what I would do here is not use a set of coordinate, because I'm pretty sure this will be a bad data structure for part 2. But I don't know if you should really... I don't know. Should. I don't think I want to overbuild part 1 just because I think I know what part 2 will probably be. Even though I think I'm probably right, it's kind of building a... I don't know. A good domain model, in some sense, is just the set of coordinates, right? That's the input. And then... in part 2, I may need some richer understanding of the data, but I can process the input into that richer form when it's appropriate for specifically part 2. So I think I'll stick with the simple model for part 1. So part 1 is just maximum of, let's say, map area of do. S from, well, I'll call them T and S, I guess. Yeah, if you have two things, often we name things S and T or M and N or P and Q. And usually, what do you use S and T for? T is for time, S is sometimes speed or something like that. But you name the first one in PQ, for example. You name the first one P because it's a prime, and the second one Q because it's the other prime. But what if you had a thing called a crime, a Q rhyme, and you had two of those? You would call them probably P and Q, but wouldn't you call the first one Q and the second one P? Is it crazy to call the first tile S and the second one T, or... I think I should call the first... It doesn't matter, obviously. Let's call this one input. Oh. I'm just re-implementing a built-in function. Actually, is that even... Is toList in the set? It probably is. But it's the same as the one in Foldable, I assume. Boy, you could be really... pointlessly clever and use the function monoid here to make this entire function point free, but it's just evil. Don't do that. Unless you want to, and then do it. Area of... So I'll uncurry the area function. S and T. No. Area of x1... they're y and x. y1, x1, y2... Should I just call these... I don't know. I never... are these good names? They're fine. But could I be, could I call them A, B, C, and D without getting confused about them? No, probably not. So we can just say dim of y1, y2 times dim of x1, x2 dim of AB is the abs of A minus B plus 1. I think that's how they define area, right? In the large rectangle 0, area 24. Yeah, so these are the two corners, and they only differ in y by 2. 5, and 7. But the width is supposed to be the height is supposed to be 3. So we're adding 1 to the delta between them. This looks okay. What do you think, GHC? You ain't liking it. Yes, that's true. These are not... I always forget that I always define a coord type, and I always forget that I've done it. Oh, this one actually should have been, okay, because this is a pair of coordinates. Okay. All right, so what have we done here? We've said convert the input set to a list and tuple that list together with itself in every possible way. Take the Cartesian product of that list with itself, tupling up the results. Find the area of each pair and the maximum of those. And area is just the y dimension times the x dimension, and the dimension is, you know, that the size of that dimension plus 1. So, all right, so you're gonna have missed some stuff here. Not much. I haven't written much code, but it turns out that right as I was finishing up part 1, when I was trying to perform some tmux command, I accidentally hit the hotkey that mutes OBS. And so I think, anyway, so I'm going to edit these together, I guess. I had just written what turned out to be the correct implementation for part 1. And I ran it and I got this number. I don't think I was just about to run it and then I muted myself. I used to struggle more often than I do these days with accidentally muting myself and staying muted for much longer. Like, it still happens on occasion, but not as much as it used to. These days, I've given myself the ability to, like, edit my voice out in post, and so there's really no reason to ever mute, except that I don't like having to edit stuff, and so I still do mute myself. For things like this, though, I don't know, I should probably just take away my mute hotkey. I can't be trusted with it. So, part 1, you saw me implement, I think, the entire thing, but you didn't see me run it and get the answer, which was correct. I guess I'll read you part 2 again. Spoiler, I did not correctly predict what part 2 was, so it's good that I didn't go to a bunch of effort to over-engineer part 1. Part 2. The elves just remembered they can only switch out tiles that are red or green. So your rect tile can only include red or green tiles. In your list, every red tile is connected to the red tile before and after it by a straight line of green tiles. The list wraps, so the first red tile is also connected to the last red tile. Tiles that are adjacent in your list will always be on either the same row or the same column, so it's always vertical and horizontal lines only. Using the same examples given as before, these tiles with X's are green. In addition, all the tiles inside this loop of red and green tiles are also green. So in this example, these are the green tiles, yes. The remaining tiles are not red or green. The rectangle you choose still must have red tiles in opposite corners, but any other tiles it includes must be red or green. So, for example, from here to here is no longer legal because it would include these non-red, non-green tiles. And I had not really written any new code. I spent 20 minutes musing about what the approach should be. And I think I settled on something sort of reasonable, but I hadn't gotten around to doing it. So let me just talk you through what the plan is. First of all, there wasn't really any reason to use a set. The first thing I did in part 1 was take it apart into a list so I could iterate over it. So I've removed that set stuff from part 1. And from prepare, we no longer call set s from list. So I realized that I think the idea that I had for over-engineering part 1 would actually still be useful. if I could, if I had a map that stored for every coordinate, like what color the tile is, red, green, or nothing, then I could still go over all the corners of the map, all the red tiles, each pair of red tiles. Let's say I was thinking about, oh, I want to do something from here to here. I could then, instead of just computing the area, I could say, first, is this legal? How would I determine if it's legal? Well, get the sub-map. If I had a map from, like, as I was saying before, row number to the rows, I could say, give me the submap containing just these 3 rows. Then, for each of those, give me the subset containing only these columns. And I would then have, like, a list of, well, yeah, I guess a list. But I'd have like a 2-dimensional data structure, a map of set or something like that, that covers all and only those tiles inside the rectangle that I'm considering making. And I don't even have to query each tile individually. I can just say, is the sum of the size of those sets equal to the area of the triangle that I'm making? Not triangle, rectangle. If so, then it's valid, and if not, then it's not. And I figured that out pretty quickly, that seems like a viable solution. But I spent a lot more time thinking about things before I started doing it, because just labeling, figuring out how to label these tiles as X's, is not totally trivial. Finding which tiles are inside of a polygon. One approach you could take would be to flood fill from the outside of the grid. And if you bump into an X or a hash, you stop. Color these as white, and then anything that's not white, you color green, basically. There are problems with that, like when the if the polygon like curls up against itself, you can end up with spots that are kind of surrounded by the polygon but not within it because of orientation. And you can also have the opposite, spots. Well, wait, no, you can't have the opposite. It's just the same thing. But you also can't start from a single point that you know to be inside the polygon and flood fill from outside there, because, like, let's say from here, let's say this were red instead of green, and then it connected to this, and then to this, and then back up to here, then these 2 cells would be cut off from the rest. So you can't just pick one starting point inside or outside of the polygon and flood fill it. So my plan is to, when I build the, like, I'll lay out all the red tiles, and also lay out green tiles as I'm doing so, just along the borders. And then do a second pass where I go over all the red tiles again. And for each green tile that I placed, I'll reach one inside in the direction I know is inside. Mark that one as green and flood fill from there. And in that way, I believe you definitely do get to every cell that's inside the polygon. Because everything inside the polygon must be touching something, that's touching something, that's touching something, and so on, that's touching the border. And if we try to reach inside and that tile is already green, we can say, great, someone else is handling this. Maybe because we already flood filled from, like, you know, here to here. Or maybe because it's just the polygon, like, running parallel to itself with no interior, and there's nothing to flood fill. Like, the 2 edges are touching. So I think that's fine. I wanted to, though, check that the polygon is of reasonable size, because the coordinates of my polygon in my input, are like 5 digits, which means 10 to the 5th, x coordinates and y coordinates, right? So around 10 to the 10th total cells in the grid. And I even, I told Haskell to count to 10 billion for me as fast as it could. And it took a minute and a half. And if you have to do anything more complicated than increase an integer 10.5 billion times, it's going to take a while. So I wanted to, before I get started on all this, confirm that my polygon is of reasonable size, even though the grid itself is very large. And so that was sort of where we left off when I muted myself. I was looking through the Wikipedia article for computing the area of a polygon from its vertices, which was useful in a previous year of Advent of Code, because the area of something was actually the answer to one of the problems. And it was a little bit trickier that year because you had to get the area exactly right. Here, I just want a rough approximation. I don't care if there's a couple off by 1 errors based on the weird, like, integer nature of our plane versus the continuous nature that this is designed for. I don't care about that. I just want to know, is it like 10 billion big or is it like 10,000 big? And there's a few formulas listed here, and I remember everybody, including me, in the year that that was a thing you had to do for Advent Code, used the shoelace formula, which is designed, you know, it's sort of easy to do by hand, in a way. You iterate over pairs of points that are adjacent, and there's this computation you can do on them that's like multiply the diagonals and add or subtract depending in an alternate fashion. But it was like kind of a nuisance. And this formula, like these formulas look really easy, don't they? Like just sum for I from 1 to n, yi times, and then like look up. So as long, if you can just look up x's in your list instead of kind of doing it in a streaming fashion, it just seems easier to implement it one of these ways. So I think I'll do that. And that was, well, I was about to explain a stupid thing, a stupid dog trick. What stupid people trick? That you could do to use to make this function point free so you don't have to mention the input argument, but I don't recommend it as a good idea, and I'm already like kind of tired from doing all this twice, so I'm not gonna take a detour into how to write bad code, I guess. But I was about to change part 2. It produces an int. So I just want part 2 to compute the area of the polygon is my plan. Corners equals for I from 1 to n, do I really want to do things at 1 indexed? I don't think I have to, right? I can just do the wrapping. If it asks for x0, that'll be x minus 1 for me, which will be wrapping around. Okay. So it's sum of, what are these exactly? Triangles or chunks? I don't know. Call them chunks because they, I guess, are parts of the polygon that are being added up together somehow. Yeah, div should have high priority. So we're going to add up all the chunks and then divide the result by 2. Chunks is do y is from length corner, 1 to length corner. Maybe I will do it 1 indexed. Why not? Pure of corners. Well, let's see. Get. Let's find a get function. Get of n is corners n minus 1, and we'll just work. This will be the one place where we convert to 0 indexing. Let's let n be length corner. Get of I. There we go. I is better. I minus 1 mod n. And let me just confirm again real quick. Minus 1 mod 5. This should be 4? Yes. Okay. So let's choose y from 1 to n. Oh, it's coming out so nice. It's going to look just like Wikipedia. No, I from 1 to n, excuse me. I'm actually going to give these names y, x, int, so that I have accessor functions for them. Pure of y of get I times, this is just copying from the Wikipedia page here, x of get I minus 1, yeah. Subtracting from that x of get of I plus 1. And so this is inefficient because we're doing linear lookup in a list, but it doesn't matter. This isn't even going to be part of the committed code. And it's a small enough list it should run very quickly. Okay, this compiles. Name. It's pretty big. $7 billion? Are you for real, bro? That's like almost the whole area. Huh. Well, that's annoying. Because like I said, doing anything, like, I could be a little more efficient here. And instead of storing the tiles that are green, I could store the tiles that aren't green. Then I'd only have like 3 billion of them. But that's still an awful lot. Right? You can't even like... If an int is 8 bytes, which is pretty normal these days, then storing 3 billion of those, that's like 24 gigs of RAM. So that approach is just not going to work. I'm glad I didn't spend a lot of time trying to implement it. Oh, there is one problem, actually. I forgot to have the polygon connect to itself at the end. So let's say this is the input. Corners is input plus its own head, basically. Yeah, didn't make any noticeable difference. In fact, no difference at all. It's a little bit surprising, but maybe that's how... Yeah, that makes sense, actually. The area formula should kind of assume that... Right, if we look at this function... I don't know. Does it? I guess it doesn't care about x1 and y1 happening again. But of course, it doesn't assume that you give it the start point twice. Sure. Okay. So this is not going to work then. I can't store this map. And, well, okay, so, but like, this number, that's around 5 billion. That's the area of the largest rectangle I could make, ignoring red or greenness of tiles. So if I don't have some fast method for finding whether an area contains green, like, then I would need to do something 5 billion times for this rectangle to check that all the squares in it are green, right? I need to be able to cache that information somehow, or else compute it very quickly. Like, so quickly that I don't even look at every point. If I just say... given, like... Well... So one thing you could do is just say, like, here's 2 corners I'm considering working with. Are there any red tiles on the perimeter of what I'm building? In this case, the answer is no. Is that enough information, though? It's not, I don't think, because you could imagine... Like, is there a good example of this here? Maybe what I'm imagining is impossible. I don't think it is, though. This polygon is just sort of convex. But if it were not, you could imagine, like, let's say I wanted to draw from here to here. Maybe this line, like this cell doesn't have to be here. Maybe it's, like, maybe the polygon goes like this or something, right? There doesn't necessarily have to be one here. So we could have these connected up with nothing here. But there could still be a different part of the polygon. Well, okay, this one's not allowed because all these are green. But So we want a similar example that's inside, I guess. Or all these are non-green? They're all outside? Like, okay, from here to here, it's not enough to just look at the edges of this polygon, of this rectangle. Because you could imagine this line kind of spiking up into here, going over and coming back down, while still not touching this perimeter at all, without leaving any red tiles in the perimeter. But there would have to be a green tile in the way, I guess. I don't know. If I can't even afford to store for each tile, whether it's green or red, I could probably afford to do that on the perimeter, right? I could actually mark these tiles as green if that were helpful to me. And that would mean I could, for example, traverse this perimeter of the polygon, the rectangle I'm considering making. And I could find whether well, I could find whether there's a green tile in here that comes from something other than the perimeter of this itself, I guess. I'm not sure if that would be helpful, because like it would let me detect a spike coming up from the bottom into this area. But that's still not enough to tell me, like, you know, are there any tiles? Well, maybe it is. I could walk along the border and of my proposed rectangle, looking for green tiles. No, but how would I know if they were green tiles from placing these tiles or from some other ones sticking in? I might have to go away and think about this for a while. This is asking, like, for some novel algorithm. I mean, probably not novel, but novel to me. Novel algorithm. Because the space constraints don't permit you to use the obvious one, I don't think. Unless I've grossly misinterpreted the area formula, but I mean, I got a number that was possible in the right ballpark of things I might be looking for, right? I'm surprised it's as big as it was, but it's not impossible. And the implementation seems pretty simple. Let's review that real quick, I guess. Part 2, sum the chunks, divide the result. But oh, wait. Is it supposed to be sum? It is, right? It's not product or something? Yeah. Sum for I from 1 to n, yi times xy minus 1 minus xy plus 1. Yeah, that looks right. And it turns out we actually didn't do this part, I guess. N is the length of the corners, yeah. Get is subtract 1 from I because it's 1 indexed. And mod by n. Yep, that all looks right. Well, I guess one thing I can do is, let's say I was considering from here to here, my favorite example, rectangle. I could look inside that area for red tiles, right? I think it's uncontroversial to say that if I chose the right data structure, I could do that. But how would that help me? Well, every red tile that's on the border of the shape has 2 green tiles next to it and 2 non-green tiles next to it. Like, well, there's a difference between like this corner and this corner, right? It has 2 tiles that are part of the perimeter and 2 tiles that are not part of the perimeter next to it. Right? So it seems like I could somehow, like if I found a red tile in the middle of my shape, like let's say this tile were red. It would definitely have to have, on 2 sides of it, green tiles. And on the other 2 sides, it might have green tiles. Maybe. If it were like... Oh, actually, is that possible? Well, they could be green tiles, they could be part of the interior, but I don't think they could both be part of the edge. I don't think you could have 4 green tiles that are all part of the perimeter next to a single red cell, could you? How would that work? Because, like, okay, let's say this red cell is connecting a cell over here and a cell down here. This and this would be part of the perimeter going through the red cell. Oh, it could have cells part of the perimeter. There could be, like, this could be part of the perimeter, and this could be part of the perimeter, and so this could be completely surrounded by perimeter. And the problem is, even if I found out, like, if it has 2 perimeter cells only next to it, but it's part of the interior in the way this one is, like these are part of the inside, then it's not constituting a problem for me. Right? I guess it would be, like, this would be a better one to draw to point out that this one's not a problem. But from here to here, this one's not a problem, but this one is. Because it has its 2 corners that aren't perimeter are outside the shape. But I still don't think... I don't think just looking at red tiles inside the perimeter solves your problem. Because there's still this whole issue of something like spiking in from somewhere far away, right? Like, you could imagine a shape... Like, let's say I wanted to connect this one and this one. But instead of this and this being here, this one went up really far, connected over here, dipped down all the way to here, and then went back all the way up and out. There would be cells in the middle that are cut out of the polygon by that big dip, but still no red tiles at all in this rectangle. Right? So I don't think you can just look at red cells inside the rectangle you're considering, because there are situations where, despite there being no red cells in that region, the region still is not full of green cells. Now, I think it is the case that there must be, in order for there to be a problem, there must be perimeter cells, either red or green, in the area you're carving out. So you could save just the perimeter of the shape in a map, or set, or whatever. And then look for perimeter cells within the area you're defining. Well, and every perimeter cell should know, in principle, which side of it is outside of the shape, right? Like this perimeter cell, when I add it to the list of perimeter cells, it should know that its south is outside and its north is inside. It can tell that because I got there by drawing from here to here. And so, like, or maybe from here to here, either way. the direction clockwise of the direction I was tracing the shape in. Or counterclockwise, depending. Anyway, there is some direction that I could figure it out when drawing out the shape. And so we could, I guess, query all of the perimeter cells in our proposed rectangle. Ask each, hey, which side of you is not part of the shape? And then look at what is on that side of it. And if it's a red or a green cell, then fine. The shape must be running two lines parallel to each other with no space in between, and that still counts as inside. But if any of them say, oh, on that side of me there's nothing, and that square is one I was trying to include in my rectangle, then there must be a square in the rectangle that isn't in the shape. I think that might work. Let's check real quick. Why do I have corners equals input? I don't know. It's a mystery. I was planning to... Oh, because I was going to do it by wrapping around by one, and then I ended up not doing that, and so now it's... Okay. This actually should well, I guess it doesn't matter. So I want to compute the perimeter here and make sure that at least the perimeter I can store a map that size. I assume that should be okay. Whistle? I'm supposed to be aware that I ended up not using, I guess. Let's actually put this stuff into a where specifically for area, I guess. And then have a separate definition of perimeter here. I think I want this in the outer one, actually. I need it because, yeah, that's how I define n. Distance of chord y1, x1, chord y2, x2 is... I think I can just add together... I can subtract y's, and that might be 0 or it might be a number, and the same thing for x's, and just add them together. Right? Does that seem okay? No. 2 ints, please. Good. Yeah, that's only 500,000. I can handle 500,000 objects in a map. So how... Okay. Let's define this. Just so I don't have this be part of part 2 permanently. So how, in part 2, how do I determine what, like, which way the shape is oriented? Like, if the first line I trace out is from here to here, then I'm going clockwise around the shape. But I don't know that, because I might very well be in the position that I was tracing this one to this one, and that's going counterclockwise. And just the mere fact of this turn doesn't tell me anything. I feel like it has to be... Only when I draw the last line do I know for sure which way was clockwise all along. Right? Like, when I get... Let's say I started here and I was going this way. I still don't know. For all I know, this part is the shape, and we're about to go like this to connect back up. But when I finally get to here and connect back up to the start, now I know, aha! Although I think I still can't tell it from this line, can I? It has to be somehow from the like what turns I've taken. Like if my first move from this point was up, and I returned to this point from the right, I think that's the point. Isn't it? No, it's not. Because I could have gone up. I could have gone like this. This could have been my shape. And then stuff below this line would be in, and stuff above it would be out. This article talks about orientation. Positively oriented counterclockwise sequence of points. Yeah, but how can you tell? This doesn't mention orientation. Pointed polygon testing, okay. For a simple polygon and a query point is Q in P. This can be done linearly. Can process okay. Oh, this is interesting. Maybe this is what I want. No, but I can't call any function once per cell inside my possible rectangle. The rectangles are too big. I don't think I want the convex hull of a simple polygon. No. A triangulation? I don't think I need that. No. No, no, no. It seems like figuring out whether this set of shapes I've been given is clockwise or counterclockwise should be easy. Let's think about rotations a little more. Because if I start from here and go here, I'm kind of facing north. Right? West, north. So, like, when I get here, I'm facing east. Well, I'm facing west, excuse me. But as I said before, for all I know, like if I only look at these two segments, I can't tell whether I went around the shape clockwise or counterclockwise. Because, or wait, can I? This path is clockwise. But if we were doing something like this, it would have been counterclockwise. And everything would look the same from this point and this one, I think. Okay, I'm going to go, like, Google around for a sec. All right, about 3 seconds of Googling revealed that I already know the answer, because the signed area of the polygon tells me whether it's oriented clockwise or counterclockwise. Right? I computed that area. Yeah, so yeah, polygon area formulas. So this is where we were looking at the shoelace formula. Blah, blah, blah. If it's negatively oriented, yeah, so... And that's what tells me, I guess, whether I should be looking at the right or the left as I'm tracing out the shape. Okay, can we, maybe what I should do is actually parse this example input, which we know 7, 1, God, what is their crazy orientation they use here? I think this must be 11-1 in their system. No, 7-1, I mean. This is 0-0. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Plus 4 is 11, then down here. Yeah, okay. So a shape oriented in this way, we're looking clockwise of the line that we're drawing to determine what's inside the shape. And therefore counterclockwise to see what's outside. So, okay. If I say... the area of this is minus 30. So negative area means that when tracing an area out, counterclockwise to that is outside the shape. Or, yeah, counterclockwise, the direction you trace the shape is outside the shape. And our area is also negative. So we could just use that. It would be nice if my program could handle shapes being traced in the opposite direction, and if it analyzed the area first to determine the orientation as part of the program rather than externally as me hard coding it after checking it once. But I still am not 100% convinced about... So I can write down all the green spaces along the perimeter as I trace the shape out. And for each one, well, oh, I can do better maybe. Because I don't just have to mark each green tile with, hey, this is the direction that's outside the shape. I can, as I'm tracing out the shape, take the direction that I know to be outside the shape and mark it directly as, hey, this is not in the shape. Right? And do the same thing at red tiles as well. Because for a red tile, there are actually two neighbors that are outside the shape. These two, for example. And then two that are inside the shape that I don't need to worry about. So, like, first trace out all the red and green tiles and just place them. Then go over the shape again And when I see a red tile, based on the direction that I'm traveling towards it, and the orientation of the shape, I can look at the two tiles that could be outside the shape. Like, let's say I'm going from here to here. I'm traveling up, and because I know that counterclockwise is out, then counterclockwise of up is left, and also the direction I was traveling in. Oh, no, that's not quite true. Okay, so when... So when connecting two red cells, I guess, what we can say is that the cell, like if I go from here to here, the cell behind the one I start with should be marked as outside the shape. And the cell after the one I stop at, here, should be marked as outside the shape. And I don't even have to know the orientation of the polygon for that, funny enough, for the red ones. I do for the green ones. And now, you may say, well, but we haven't marked this one. That's outside the shape. Well, that'll be handled when we go from here to here. I'll mark this as outside the shape. Fuck. But then I was going to be wrong for this one, because this actually is inside the shape. Shoot. So it's not so simple. Okay, so I guess, though, if I know this polygon... So it is true for a polygon, a vertex that's an outside corner, kind of a convex corner, right? The one in front of it, the one after it should be marked outside, and the one before it when I leave. So if I identify that a corner is convex, I should do that. And this corner is kind of concave. It's inside the shape. And I don't need to do anything. Like, the one in front of it is still in the shape, and when I leave it, the one behind it is also still in the shape. So, if the direction that I'm turning is the same as the direction I'm tracing the shape, like this is a clockwise shape that I'm tracing, and if I'm making a clockwise turn, then this point is convex. If I'm making a counterclockwise turn, this point is interior. Is that true? It seems to be. Because this is clockwise, the same, and it's exterior. Clockwise, exterior, clockwise, exterior, clockwise, exterior, counterclockwise, interior, clockwise, exterior. So I think that makes sense. So go over the shape once, placing down all the red and green tiles. I mean, I don't think I have to go over it twice, do I? Go over it once to determine its orientation, clockwise or counterclockwise. And then go over the shape. But when I'm taking the first point, okay, it's so fiddly. When I'm going from here to here, how do I know that I'm leaving a convex point? Because I don't have a defined turning direction. I'm just going up. So maybe I don't do anything for this first point. But then every point I pass, if it is supposed to be marked green, this shape is being traced clockwise. So whatever direction is counterclockwise of the green that I would be marking, I add that to a set that says this is outside the shape, right? And then I'll have kind of drawn the outside border of the shape. And I have to also handle the red ones, which I think if I just like start if I just like handle the start point twice, oh boy. Well, if I handle both, the first 2 points, if I include them twice, then I'll have a full turn from here to here to here when I'm done, right? And so I just won't do... I'll just handle... Yeah. Like each... I'll zip the list with its tail, but I'll pad on an extra copy of the first and last item in the list. Sorry, of the first 2 items in the list. I guess first and last would be okay as well, but... Yeah. And that way I can just look at each pair. Oh, each triple? Ooh, yeah, each triple! That's why I'm having so much trouble. I'm thinking about pairs, but I can't tell from 2 points what direction I'm turning in. If I looked at triples of points, it would be so easy, right? I would know, oh, this is a left turn. And, or, well, a... It's a turn from north to west, which is counterclockwise, I guess, right? So I could look at the middle point of each triple, and that's the one that I decorate the corners of, because I actually do have a defined angle there. Right? Compute the direction going into that triple and the direction going out. And if the input file is weird, it could actually be straight, and then I won't do anything. Or I'll mark it the same as a green tile, I guess. Okay. But normally the direction will either be clockwise or counterclockwise, from north to west or north to east, for example. And if that direction is the same as the orientation of the shape itself, then it's an outside corner, and if it's the opposite, then it's an inside corner. Outside corners will mark, inside corners will leave alone. I think I'm getting there. I think I finally am starting to understand an approach that could work with the space constraints we have. Okay. So how would we start working on this? I think we need to start defining orientations, right? I don't think I need any of these things, but there you go. And I need a direction. Okay. And I need a few functions involving these things. For example, I need a function that takes 2 coordinates and tells me the direction of the line segment from the first to the second. Let's make to and from more clear. Oops. Oh my gosh, that's so far over. Let's write the function over here. Where, yeah, I mean, I'm gonna have to... So if y is... negative, we're going north. If y is positive, we're going south. If x is negative, we're going west. Yes. If x is positive, we're going east. From -2 or 2 minus from here. If y is... If 2y is smaller, then I want dy to be negative. So I want 2y minus from y, I think. Okay, does this compile at all? I called it data, huh? I said it returns a coord. How about if it returns a direction? Yes, I'm not handling other patterns, sure. So for example, let's test this. If I said travel direction of coord 0, 0, if I were to go to 10, 0, that's y increasing, which should be south. Yes. That's north, sure. And if we want x increasing, x goes to 10. That's east. Great. Okay. So I got all the signs right. Or at least they mean the things I thought they would mean. Whether what I thought is correct, I guess we'll find out. I guess I do actually need a null rotation. Because I want to be able to like say, hey, given two directions, what's the rotation to get from the first to the second? No, I don't think so. I think I should return a maybe rotation instead, because I want to also use rotation to say what is the direction, the orientation of my shape. And I don't want to have to keep checking, oh, is that orientation straight? That's impossible. So I think my rotation is going to take two directions and return maybe a rotation. I guess I should be using the enum instance here, huh? Because I did write them out in clockwise order like a good boy. So if you were going north and you're now going east, that's clockwise. Rotation of old and new, I guess? Case... from enum old minus from enum new mod 4 of. So if this is 1, then what would be that? That would be an example of going from east to north? Or no? Old minus new. So that would be... If old were... If old were east and new were north, we would get 1. That's counterclockwise. And if minus 1, clockwise. Otherwise, nothing. And put those justs in there. So what's the rotation if you're going from north to east? This should say clockwise. Ah! Really? From enum old, old is north, right? Yeah. Minus east. East is 1. 0 minus 1. That's minus 1. That mod 4 is 3. Yep, you're right, that's wrong. This should say 3, not 1. Because we'll never get an answer of minus 1 since we do a mod 4. Well, we might sometimes get an answer of minus 1. No, well, if we did, it would turn into a 3 because we're working mod 4. Okay, try again. To go from north to east, you are turning clockwise. Correct. And to go from south to east should be the opposite. Yes, great. From east to west, yeah, that's nothing, man. East to north should be counterclockwise. Good. Okay, we're getting there. Way more working with orientations and directions than I thought we would be today. There's got to be some simpler way to do this whole problem that doesn't involve this, but I was not able to think of it, so this is what we're doing. Let's start writing some lets here. I guess. Maybe this should all be aware, but there's a lot to write, and it feels more natural to me to write things with lets at first. Let orientation equal orientation if the first of dimensions of the input is less than 0 equal counterclockwise, otherwise equal clockwise. So let's just actually leave off this for now. Why let's just write it in the where? Orientation. So first of all, let's just confirm that this gives me orientations, what I wanted. The shape is counterclockwise, which is what we determined, right? Okay. So I think I should lay out I want to put down all the red and green tiles somewhere first, and then go over things again, checking if there's a red or green tile in a certain position, and if not, put down like a black tile. That means this is outside the shape. But I don't want like a single data structure that contains green and red and black tiles, because I don't think I ever need those. there ever be, before I get any further on this idea, can there ever be, when I'm deciding I want to draw this like rectangle, let's say I want to draw the one from here to here, can there ever be a cell that is not, certainly there could be, a cell that is not part of the shape, but also is not next to a wall. For example, this one here. It's not next to any of my walls, and it won't be, and it's one of the reasons you can't draw the rectangle from here to here. And I won't be putting it in my data structure because I'm only looking at the ones adjacent to walls. I don't think I care about that, because any such black cell must be accompanied by another black cell that is touching a wall. Because otherwise, how did we transition from being inside the shape to not, right? I think that's true. There must be a black cell that is touching the perimeter, if there's one that isn't. I think that's true. So if I could just put down all the black tiles that are touching the perimeter, and then I query, are any of those in the rectangle I'm proposing drawing, I should be okay. Yes should mean go home, no should mean, yeah, that's fine. What do I want to do after computing the orientation? I guess I want, like, input prime to be input plus the first two elements of the input so that I have them tripled up with each other. Corners is zip 3 input tail input and edges. Let's do edges first, actually. And I think actually at this point, I don't really care about the distinction between reds and greens, weirdly. I care about corners and edges, and then I can just fill a set with, oh, this is either red or green, basically. The red ones are just the input, right? So I could say reds is just input. I don't even need input prime because I'm not actually drawing the edges in, right? greens is I think I want to say like a do notation over all the edges, right? Is no. Point coordinates are not numbers. Okay. I knew that, but I had to check. This delta thing is actually useful, isn't it? But I think it's backward. No. If we're moving north, y is decreasing. Yeah, so I actually want I want this little delta function. And then here I can just say from 2 case delta from 2, like so. Oh, except this is expecting a pair, not a coord. Annoying. I kind of like this returning a pair. Turns out maybe I didn't want these stupid coord types anyway. This isn't exactly a coordinate. It represents the delta of a coordinate. Like, it isn't quite right to have that type be represented by a coordinate, even though they happen to be the same representationally. There's a bunch of things that are illegal for directions, right? Really only -1 and +1 should be allowed. Oh well. So I have this delta thing, which I was using here. Yeah. From 2 edges, right? Dir is step? I don't know. Delta from 2. And then I want... I want, like, to iterate adding the delta to the from until I get to the 2, right? Take while not equal to of drop the first one, I guess. I think it would be fine to keep the first one in. Because that should be the corner. And the corner is already included in reds, and I don't care about the difference between reds and greens. But just to be clear, let's drop 1. Drop 1. This is kind of annoying because I'm going to be traversing these edges and corners twice. Once to put down the reds and greens, and then again to go around the shape and mark everything that should be outside the shape and isn't already red or green as black. It would be nice if I could just like emit kind of candidate blacks and definite reds and greens in a way. Does that make sense? And then at the end, I would just remove from the candidate blacks all the reds and greens. Yeah? I guess I could do that. So we don't want S from list here. We want M concat, I guess, of do. Dir equals, what did I just call it? Direction? Travel direction. Of step. Outside step. God. I hate having two different representations of direction, right? My rotation and this direction is northeast, southwest, but I don't have a good way to convert back to this. Okay. Yeah, I guess step is okay. Step, dir. North. Luckily, I have all the answers right here. I don't have to think about them again. Just have to write it again. North, south, west, east? What the hell is wrong with me? I'm swapping the order of these. This shouldn't be a tuple, it should be two expressions. All right. And now step dir is just the function I need to iterate. And it's also what I can use to look outside. So I don't actually... Do I need this delta? No, I just need the travel direction. Travel direction doesn't even take one arg, it takes two. This was never like this, right? Yeah. So I'm going to be producing a list of pairs. Things that could be black and things that definitely are green. And I'm calling mconcat on a list of pairs. Yeah, that'll all work out fine. Well, outside direction. I have an orientation. I have a rotation function. No, that's not what I want. God, am I missing another fucking function? I am. I want a function that does the opposite of this. It takes a direction and a rotation and gives me a new direction. Okay. Takes a rotation? Yeah. And a direction, back a new direction. Fortunately, I think it's pretty simple. Rotate R RD is from enum D plus dr, dd, I guess? Mod, probably need parents here, 4, and then put that back to again, where dd is case rotation of, if clockwise we should add 1, if counterclockwise we should subtract 1. North to east, that's clockwise, add 1. East, north, that's counterclockwise, subtract 1. That all works. Okay. So if I'm tracing the shape clockwise, and I'm traveling east, then what's outside the shape is actually counterclockwise. So I need like an inverse rotation, I guess. Invert. Simple enough. Invert orientation. No, that's my rotation. I want to apply that to my travel direction. Rotate in the travel direction, invert the orientation. God, this is going to be impossible to test if it's wrong. Well, I have the sample input I can run it on and get something sort of meaningful from it, maybe, if I stop part 2 early. Like if I just tell it to output the blacks, the greens, and the reds or something. Oh, actually rotate takes its arguments in the other order, which seems like it would be clever, but at the moment it's the opposite of what I want. I guess I can't just write a do because I need to stop when I need this like take while, right? Well, maybe what I can do is say do tile comes from this maybe. Iterate step in the dir of from, like this. These are all the tiles that we're visiting that we're going to mark as green. And then we'll say step in the outside direction from tile and then the tile itself, right? Does this make any sense? I assume it doesn't compile at all. I haven't even imported sets yet today. Okay. A million things wrong. An equation for delta, huh? Oh, this was supposed to return. Okay. Yeah, that was only 2 errors. Line 52 has the wrong case for something. Should be R, not rotation. Travel direction is applied to too few arguments. Oh yeah, this should just be dir. I mean, I guess I don't really need this dir at all. I can... No, I use dir here and here. Sure. This is from monoid coord. Yes, that's completely my bad. I'm building 2 sets, not 2 coordinates. All right. Binding for delta shadows the existing binding. Uh-oh, that's a little worrying. Oh, I could call this something else, I suppose. Call this magnitude. Bunch of things I don't use, which is fine. It's as desired in a way. So let's say then that part 2 just returns greens. "22 tiles. Is that right? Hard to tell. We're only counting greens here, so 3 plus 5 is 8, 9, 10. Plus 6 is 16, 17, 21, 22. Is that the number I came up with? It is. So that's probably right. It would be quite a coincidence if I got that right by accident, right? And so let's have a look also at the candidate blacks. For example, let's have a look at this one. Y6X2. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2. Well, I didn't mean to mark this one. I was only trying to mark this. It's true that this is outside, but I didn't mean to do that. I don't think. How did that get there? So we're starting at from, which I actually don't know which order the input goes in. So it goes from 9.7, this one, to 9.5. So to get here, we would have been traveling from no, wait, what am I saying? This one is at 6.2, isn't it? 6.2 is not here. All right, what? Okay, you think these are 2.5 and 9.7. 2, 5. I see. So you're rendering this oriented differently than I am. You're rendering x, y, which there's no difference here, right? The coordinate system is arbitrary. I'm choosing to interpret this as yx, but it doesn't matter. But to understand this in relation to the diagram, I should interpret my numbers backwards. So where I have y6, x2, I should consider actually that's x6, y2. So where is that? 1, 2, 3, 4, 5, 6, 1, 2. That's here. Perfect. That is outside. I wanted to mark that. And in the in here, we don't have anything adjacent to that, which is perfect. Because in the diagram, there are no... Well, wait, that's not true. we should have this one. But it won't necessarily be adjacent because the sort order is different. So we should check, though, that 1, 2, 3, 4, 5, 1, 2. So this is like y2, x5 in their diagram, which is y5, x2 for me. Which I do have. So I think this is looking good. We have y5, x2. Y5, x... I don't know. So, yeah, this is difficult because it's a... So let's look over here, maybe. Because these should have the same y coordinate in my graph. They should actually be next to each other. So this is x 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So x12, which is y12 for me. And x2. So 12. So y12 from like 2 to 6 should all be in there. And indeed, that's exactly what we have. So I think we have correctly labeled the edges, the outside of the graph that is next to a green tile from the perimeter, which is what I wanted to do. Perfect. We're not done yet, but we're getting there. So now I just need to do a similar kind of thing for triples of reds. So I can't call it candidate blacks. I mean, more candidate blacks. Now I don't need to mark the reds because I already have those. And I think here I can say S from list view, right? A, B, and C from corners. And really, I think I should just inline edges and corners. I don't know, it's nice to have them have names, isn't it? Even if I don't use them right away. I think it is. dir1 let equal travel direction from A to B. dir2 equal travel direction from B to C. And then I need to figure out the turn direction from that, which is what exactly? The rotation from old to new? Yeah. And if that turn I guess, as I've said in previous videos, you don't use if very often in Haskell. There's usually a better pattern match or guard clause version. But I think we just want an if here. If, because I want to branch based on whether two things are equal. And I don't need to case compare them or anything. I don't need to worry about any possibility except them being the same. So if Turn is equal to... So let's see. Let's go review our thing. So if we're tracing out the graph in clockwise fashion... Okay, I need to actually reconsider. I need to make sure that I have the orientations right, because... Well, I do. The orientation I found is correct for my edges, so it must be right for my corners as well. Because I realized I was treating this as YX when actually it's XY, and maybe that could have caused me a problem with getting the orientations wrong in the way I wrote them in my program, but it pointed to these squares, so my notation of orientation must be correct, whatever it is. So if our shape is traced out clockwise, and we make a turn that is equal to that, then we should mark these two spots, basically. So if it's not... Okay, so... Oh, I can actually... You don't get the chance to do this very often. Wait, what is when... Oh, do I just want guard again? I guess so. Guard that turn is equal to orientation. So if our turn is in the same direction as our orientation, continue. Otherwise, abort this iteration of the loop. Yeah, that all looks right. Then we have to look... Let's see. We have dir 1 and dir 2 already. So I just need to move from B in the old direction, because that's kind of continuing through B. And then move in the direction of dir 1, rather. Okay, so let's do this. Step in dir 1 from B, and also step in the opposite of dir 2 from B. And I don't actually have an opposite of a direction right now. Well, I guess let's write it. My directions are written in a friendly enum order, right? Northeast, southwest, yeah. So to reverse a direction, turn it into an int, add 2, mod 2, turn it back into a direction. Okay. Step reverse of... I guess actually you shouldn't need this, weirdly. Because I have I shouldn't need the reverse function because I have a rotation. And I already know, like, oh, I was going north, and I turned right. I could just turn left from north instead to get the right direction. But I don't know, I kind of like reversing the direction dir 2. That kind of makes sense. So then we can just say blacks is candidate blacks, more candidate blacks. That's probably a difference operator, I'm pretty sure. Although I want to subtract two things. I want to subtract the reds and the greens. All right, let's look up the docs for data set real quick. Data set. Loading. Google's slow today, and the last couple times I've recorded. Like, sometimes you get results fast, sometimes you get them slow. Combine. Yeah, difference is what I want, and this is also difference. But there's not like a differences function. You just have to difference twice. Infix L. So what does L mean? I assume it's what I want. If it's left associative, it's the opposite of functions, which means A difference B difference C is the difference of A and B and then difference C. Yes, that's what I want. Okay. Like this. So these are the things that are actually on the just outside the perimeter of the shape. So let's return this. Turns out it would have been convenient not to name a function reverse. I don't have guard. Usually I've imported guard by now. Because I use so many monad comprehensions instead of list comprehensions. Good point. Orientation could be maybe. Right, so the turn could be nothing if we were continuing straight. So we check A that we're turning, and B... Oh! Well... If we ever went straight, we need to handle the outside of the red anyway. Right? I bet we do go straight at some point. But let's see if what I have so far is doing what I hope it would do. We're not returning a tuple anymore. So let's go look at the test input. And I want to see this cell, which wasn't in my list of blacks before. I want to see that it's there. So in their coordinate system, this is y, well, x1, y1, 2, 3. But I've interpreted the list sideways. So it's y1, x3. Oh, and it happens to be the very first one. Great. And then we have y1, x4, and 5. Yeah, so I've handled this side here. So that looks pretty good. I'm not actually handling straight lines, though. And the funny thing is, I think it's actually really easy to handle them. I can just not do this. Because there's no harm if I have a straight line. Like if I'm at a cell going north to another red tile, like from one red tile to another heading north. And I'm about to say, oh, the west side of this line is outside the bounds of the shape. That's still true, even at a corner, right? The west of the south, the southern, the cell to the west of the southern end of this point is also outside the shape. Unless it's part of the perimeter, but that'll be handled separately. Or, yeah, I guess there is no or. And if we were going straight, like if our southern point, if we're going from a point A to a point B north of it, and the point immediately before that is C, which is south of it, and there was like no turn, it's kind of weird that there's a red tile here, but that's allowed. I can just say, oh yeah, I'll mark the one to the left of my starting point. The west of my starting point. Yeah, I think that's perfect. So let's just get rid of this. Okay. So I think we've found... This is my dream. This is what I always wanted. So what I want now is like max. Oh man. No, I need to compile a better list. I need, because I need to be able to compute submaps and stuff, right? Like I was saying earlier. Oh my god. I feel like 5 minutes ago I was 1 hour in and now I'm 2 hours in. At least I've done something. All right, so let's see. I need an int map as well, I think. Because I'm going to have an int map. From list do of... Chord y x from list width chord y x from the list of blacks M singleton pure of M singleton of y and singleton x. So in this way, I'm building a map for each black tile, which remember there's no such thing in the problem as black tiles. These are just the ones that I need to, that I've decided I should check for. I'm getting its y and x coordinates, and then I'm creating one entry in the map for its row index and giving it a singleton set saying this is the only thing in that row. But then I'm using from list with union here. Well, M append, whatever. So that if any other entries have the same Y, their singleton sets will be joined together. And so now I have what I wanted, which is a map from Y to row, where the row is a set of X. And I can check, are there any black cells in an area? So what I want is like maximum map area filter valid, something like this, of I guess I can use this. Filter valid of lift a to of input, right? Take every pair of red cells, red tiles, and if it makes a valid rectangle, determine its area. And find the largest such. And then I just need to write the valid and area. And I don't even need the area function, just the valid function. So valid of coord yx is okay. Now I need to actually look at how to get submaps out of a map from. So an int map, I'm probably looking at like the wrong. Yeah, don't use this package, use, okay. Google finds like, you have to tell it which one you want. I mean, strict would be best, I guess, but I'm not being specific, so I'm probably getting a lazy one. It doesn't really matter to me. Submap, I think? No, this is, okay, do I want filter? I want like split in a way, right? Which I know I just scrolled past, but. So filter is expensive. Partition, yeah, this is all. I think I want split or something like split. What is W? It'll be mentioned here somewhere. The number of bits in an int. Okay, sure. So if it says min of n and w, it's basically saying constant time. Right, this. If your n is large and w is 64, this is order 64, which is 0. But if your n is very small, it's a bit more efficient than that, I guess. Sure, whatever. So I guess I need this split lookup where I get or I guess I can just split looking for things that are larger than n minus 1 in a way. Okay. It gives me back an int map, which might even be empty, but that's fine. Of columns, in a way, where ignored and x, what do I call this? I mean, like m prime. I'm gonna write m prime, m prime prime, m prime 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 prime. Like there's gonna be a few of these, but equals m dot split outside at y minus 1. So is a pair map 1 all the keys that are lower than k. Oh, I need to be careful, actually. I need to figure out which one has the larger lower. I need upper and lower bounds for y and yeah, this is supposed to take two things. I actually need these parents. So now I can say min of, I think I don't need this parent, y1, y2 minus 1. Yes. So anything that is at least one more, no. Anything that is more than one less than, i.e., which is at least, what am I doing? At least the minimum of y1 and y2 is included in this. Then split that. Oh, actually, split takes the key first. So then split this so that we don't get things that are larger than the max. Y. So now I have a map whose keys are the y values that are at least equal to the minimum and at most equal to the maximum of the two y values in question, which I think is what I wanted. And I basically want... So what do I have now? I have a map. And the value of each map is a set. And the set values are just ints. They're not coordinates. I already trimmed the y value out implicitly by putting in the map. So I can just look at the x. Yeah, okay. And I assume set has a very similar split operation. Something like that. Or it has filter, maybe? Yeah, it has split. Okay. Okay, well that's what I wanted. But I have then a bunch of I have several sets inside my map, and each of them just has x coordinates in it. And I no longer care about y coordinates. So I can just say like x's is s unions? I could just use mconcat, honestly, but yeah, S unions, I guess, is clearer. Of I have a single map, m dot elems, yes, right, of yeah. So now I have all the x coordinates. In a big set. And I could do this split thing again, I guess. But there's got to be a better operation for sets, right? When I just have ints, like I want to know is anything. Yeah, like I can say. Well, it's not actually that easy. If I like say look up min or whatever, I can look up min like and say, oh, is this smaller than my x? But if there's nothing there, it's just easier, I think, to split the sets and then say is what I got back in the end empty or not. Split takes a key. Okay. Split at the min of x1, x2 minus 1 x's. Split at the max of x1 and x2 plus 1. It isn't pretty. Does it compile? No. Oh, right. I have to do the same pattern matching here. So at the lower end, we drop the first one. At the higher end, we drop the second one. What the hell? I don't know what Control-Z-Q does. Apparently that. Okay, interesting. It's not what I meant to do. Some tmux thing. I have Control Z as my tmux prefix key. I know like Control B is the default, but that's insane if you're used to using Emacs. Every Emacs user remaps that. I'm sure it's fine for Vim people. But Control Z seems so natural because the job tmux is doing kind of replaces the job that your shell normally does for managing jobs, which is mapped to Control Z. So you're not getting in the way of anything important because tmux is just handling that instead. Okay, I forgot what I was trying to do. It's not s empty, it's s null. Valid seems to take 2 arguments. Or 1 argument that's a tuple, which is what I have. Oh, maybe area is wrong. It inferred something wrong for... Yes. I have to do the same thing here. Okay, this is much better. It's inferred more reasonable things from that. Blacks is already a list. Why did I need to from list it? Oh, I meant the opposite. I meant to list. Does set define to list? It probably does. Yeah, okay. What? Oh. Right. I'm already calling m from list with, so I shouldn't be calling m singleton here. I should be returning a tuple. And letting from list with combine them into, okay. Oh, right, it's not an okay. There. Y singleton X. It compiles. Let's see what happens. Okay, yeah, kind of expensive to build the list of greens and reds and blacks and stuff. Understandable if this takes a while. We said it was like 500,000, I think, nodes. The perimeter. So that'd be about how many black tiles I end up placing. Okay, this is pretty slow. While this is running, let's run part 2 on the test input. 24. That is the right answer. Advent of code, generally speaking, does not make you run anything that could take a really long time, even on a potato. Like, the idea is if you have a potato and a good algorithm, you get the solution in, like, I don't know, a few seconds. And if you have a great computer and a bad algorithm, you might be fine. And a lot of the time, even a potato with a bad algorithm is fine because the numbers just aren't that big. Today, the numbers are kind of big, but I thought I had gone to quite some trouble here to make sure I didn't have an outrageously large data structure. I mean, it's still not small. 500,000 times... Actually, let me check real quick. I've forgotten actually how big that was. Dimensions. Yeah, 500,000. 500,000 is the size of the perimeter, roughly. The area is very large, but we're not messing with the area. So 500,000 times 8 bytes for an int. 4 million. 4 megs. Now, of course, maps and sets are very bloated representations, and I mean, a Haskell int, generally speaking, takes like 2 words because it's actually a pointer to an int. So it's like 8 megs, and I mean, I don't know, each of our ints is probably going to have, I don't know, call it 3 pointers associated with it to be, I don't even know if that's generous or not. But, like, that's 4 megs times some smallish constant factor. Say, 50. I don't think it's 50. But even if it... I think it's less. Even if it were, that would still be 200 megs, which comfortably fits in a computer these days. So, size of the data structure shouldn't be a problem. That's interesting. I mean, so and what's the... How big is the input file? 500? 500 squared is a quarter of 10,000, 2,500? No, that's too small. It's a quarter of a million, 250,000. So we're finding 250,000 pairs of coordinates. And for each one, we're doing some trim operations on a map, which I was told is constant time. Is that right? Or did I misunderstand? Where do I have a map documentation up? Here we go. Yeah, so split is constant time. Okay. So I'm doing 500,000 constant time things. I mean, I could cut the search space in half right now, I guess. By just starting with, hey, make sure that you don't you don't consider like point PQ and then point QP both. Okay, fine. I guess I'll do that. Right? We can just say, don't even bother if P is greater than Q. We already handled that one, basically, right? It's a little scary to stop the program because if I was almost done then stopping it to cut its runtime in half is actually increasing the runtime, right? But the longer I wait, the more time I'm wasting, since this cuts the runtime in half. Unions of MLMs. I mean, this could be expensive, I guess. But it shouldn't be, because, well, maybe it is. The set, because unions can be large, can be expensive, right? Union is order the size of the bigger set. Smaller set. So, okay, actually this actually could be expensive. We're doing something that's not constant time for each point. Each pair of red tiles. So I should trim this. It was simple to say, oh, let's combine all the points that were there. But there could be a lot of X's, I guess. But I guess I have... I mean, I kind of have to do something that takes order n time, because I have n sets here. I got to do something with them. But I don't have to do something that takes order n time for each of my n sets. That's quadratic, right? Potentially. So... do? Never go wrong with a do. For each set in the elms of M prime prime, do this, right? And this min, I mean, I guess we can lift out. Is there a good function that like takes two things and gives you the max and the min? Like, I'm sure it exists in somebody's library, some weirdo's library, but is it built in? If I have ord A and two A's, I want back a pair of two A's. No, there's nothing in the prelude that does that. It's like divmod, but for min-max, kind of, right? But that doesn't exist, okay. Oh, I guess I can put the -1s in here as well. This. Oh, sure, let. Okay, that compiles, so let's kill this off and try again. I cut the search space in half and turned what I think was a quadratic operation into, well, something that was linear in the product of two variables to something that's linear in just one of them, at least. Let's make sure this still works for the input, I guess. Yeah, it's still 24. Well, let's fix some compiler warnings while we're here. I guess it's fine to shadow area here. Hey, it ran. Okay. So that took some time, but not an outrageous amount of time. Much faster than it was on pace for before. So this number better be smaller than this one. 9 digits? 1.5 billion? This one was 4 something billion, right? Yeah. No, wait, this is 10 digits. Yeah. 1.5 billion. This is 10 digits at 4.7 billion. Okay. I mean, this is... It's right. Okay. I got there. I'm glad to have this, because, like, if it had been wrong, I don't know how I could have debugged it, man. Right? Look at this monster. Oh, part 2 needs a type. There's just so much going on in here. And yet, it all worked on the first try, sort of. We had some bugs earlier, I think. Did I ever get a wrong answer today? I don't remember. I don't think so. I just had some partial answers that I wasn't done with, and then eventually they were right. But this sure is complicated. I'll be interested to see a simpler way people did this. Obviously, I didn't have to make things as hard as I did for myself by modeling like directions and rotations and so on. But I think this was the right thing to do if your goal is to have something that sort of works in the domain concepts of the problem. And in a funny way, part 2 is just part 1 with an extra filter valid in it, where valid is like a monstrous function. I mean, any easy improvements I could have here? Not really. Could use some documentation. Good news! I recorded a 3-hour video describing this function, so I'm freed of my ethical obligation to add a comment to the source code. Anyone who wants to know how it works can just listen to this. Oh my god. Alright. Just commit all this shit. Do I really want all of this? Yeah. Did I ever end up using the Y and X? I must have, right? Somewhere? I don't think so. There must have been some intermediate version that was going to use it that I didn't end up... Oh, here it is. It's in dimensions. That's right. Which I don't end up using, but... Oh, actually, I do, right? Because part 2 needs to know the orientation of the shape. I guess we could look at cleaning up some of these warnings, right? I'm surprised it's not bothering me about shadowing X and Y, the record accessors. I don't know what you're supposed to do about this when you have like a local variable that has only one reasonable name, shadowing a function that also has that same only reasonable name. Like, what do you want me to do? I didn't get them confused. This is what I meant. Stop bothering me. Like, I could turn this into A and P, but I think it would be a worse function, so I'm not going to. And then, like, zip with distance tail. I mean, yeah, perimeter. Very funny. Line 117. I just shouldn't do it the stupid cute way, right? I should do it right. There you go, drop one. You like that? Now it's total. And it'll just be silently wrong if I ever get a corners that is empty. Well, I guess it won't be wrong. It'll be 0. Ah! Zip width is applied to too many arguments? What? Perimeter is applied to too few arguments. Oh. Okay. Now I'm using head somewhere. I guess I could make that take 1. There you go. Are you happy now? Almost. I'll leave that one as it is. Day 9, part 2. Alright, that was an interesting challenge. It took me a long time to work around an idea of how I could solve this without doing the brute force thing of just trying to save all the green tiles. I hope that I'm right, that I didn't have, like, that you couldn't possibly store all the green tiles. I went to a bunch of effort to figure out if I could store them all, and then when I found out I couldn't, I went to a bunch more effort to think of a better algorithm. And the better algorithm is cool. It might not be the best algorithm, but I hope it was at least necessary. I hope the brute force way wasn't going to work. That's all for today. See you guys tomorrow for day 10. Thanks for watching, and I'll see you next time.